let's pick right up where we left off. And we were working with this rational function here. And we had done this problem graphically, right? Trying to figure out when does f of x equal -4. Let's take a look at that algebraically. Okay, so this means replace f of x with -4. And this is a hard equation to work with, right? Students usually plug in and then stare at it and don't know what to do. Okay, but what we learned in the last segment is if you have something like this, think back to middle school where you learned how to cross multiply, right? So multiply this times this times this, right? Multiply on the diagonals. Be sure to distribute the -4. Okay, so when I multiply by -4, I get -4x minus 8 because I'm distributing. And then I want to solve this. Let's go to the quadratic formula for this one. Okay, I don't have it in the right form yet to be able to use the quadratic formula. That's a 4, it doesn't look like a 4. Okay, I wish we were in class so that I can ask, throw this out to the class and say, well, what do I do? Right, what am I supposed to do here? And then everyone can tell me you bring all the terms over to one side. Okay, so that would become plus 4x, and I would add 8 to both sides, and so I'd get plus 6 equals 0. Okay, so I have to be in this form before I can use the quadratic formula. All right, so let's plug this into the quadratic formula. I get x equals -b plus or minus b squared, which is 16, minus 4, a is just 1, minus 4ac. And when we were doing this graphically, we said no solution, right? There was never a place where that rational function crossed the horizontal line at y equals -4. And I can see the problem algebraically, right? That would give me a -8 under the radical, which would not be a real number. Therefore, I know that there is no real value for x that would give me an output of -4. Okay, so that's how I could have determined that algebraically. Now, moving on, I had called this section solving quadratics. Okay, but this equation is not a quadratic, right? It's a cubic, and I don't have a formula that I could plug into, right? Obviously, I can't use a quadratic formula unless I have a quadratic. So how am I going to solve this? And there's two different ways, okay? And so I got this started here by writing out taking the left-hand side of the equation, setting that equal to y, taking the right-hand side of the equation, setting that equal to y, and we can look and see where these intersect. Okay, so let's go to our graphing calculator. And sometimes the hardest thing in any of these problems is just finding the right window. Okay, so I always start in the standard window. So let's see if I'm at a zoom 6. And I do see my intersection point like way up here. All right, I don't see anything going down here that I'm interested in. Okay, so I'm going to adjust my window so that I've got a better look. And I'm actually going to change like my y min to like 4, right? Because nothing from like here down is anything of interest. So go into window, y min, as I said, I'm going to change to 4. All right, so I need to make that y max bigger. Why don't I try 20? And sometimes it just takes a little bit of trial and error. Okay, so there's my intersection. All right, I hope we're getting to be experts at this by now. Okay, second, calculate. I want intersection point. First curve, where is even my cursor? I don't even see it here. There we are. There's first curve, second curve, guess. So I get 1.77 for that answer. or 78, I guess, if I'm rounding to the nearest hundredth. How about 1.78? Now, there's another possibility. Let me go back to my y equals, just clear these out. And clear, go back to my window and do a zoom 6, so I'm back in the standard window. Okay, let's go back and look at another possibility. Okay, another possibility would be to take all my terms over to one side and set this equal to 0. Okay, by bringing all the terms to one side. And then what I'm doing is setting this equation, this equation is now equal to 0, which means if I graph this, right? So if I put this part into my y equals, right? So I put a y here, I'm looking for when y is 0, right? Well, when is y equal to 0? That I would be looking for the x-intercepts, right? That occurs when y is 0. Okay, so that's my other possibility. So if I go back to my graphing calculator and type this in, okay, go to graph. I don't think I'm going to have to adjust my window, right? And so this time when I go to second calculate, I'm looking for the 0 of the function. Okay, so this time I'm doing the left bound, right bound. So I'm to the left of the 0, hit enter. I bring myself over so I'm to the right of the 0, hit enter. And there's my 1.78 again. So here's what I'm going to have you do for participation. Let's go to this example. And there are many different ways I can do this. So I do have a quadratic equation. First of all, I ask you for a couple functional values. Now you could actually plug in 3, square it, right? Minus 7 times 3 plus 5. I mean, that's not that much work. But if you put this into your y equals, you could just go to table and find these values. Okay, so I hope you will do this using as minimal amount of effort as possible. All right, and then I want to know for what values of x does f of x equal 3, also f of x equal 29. Okay, so if I plug in a 3 here, I mean, I have different possibilities, right? I could subtract 3 from both sides, and I could be looking at this function, right? So I'm subtracting 3 from both sides, so I'd have this. I could use quadratic equation. You probably don't prefer that. I could graph this parabola, right? And find the zeros, right? Find where it crosses the x-axis. Okay, I could do that. Or another thing that I could do is I'm going to have this parabola, right? Well, when does f of x equal 3? So I could graph the parabola, and then I could graph f of x equals 3, right? So this would be like the line y equals 3. And then I could also graph the line right at the same time, y equals 29. Okay, to find where I get those as outputs. All right, there will obviously be 2 values of x. That would give me 3 as output, and 2 values of x that would give me 29 as output. All right, so please complete this exercise for your participation work.